spectrometer ID curve. The aim of our experiment is to draw the ID curve of the given prism, and using that ID curve we want to calculate the refractive index of the material of the given prism. ID curve means I is the angle of incidence, and for that particular angle of incidence there is a deviation d, and that deviation d we want to determine, and then we are plotting the ID curve. For this we are provided with the spectrometer apparatus. The given prism is here and the sodium vapor lamp. Now, as you know, the spectrometer apparatus consists of the telescope, the collimator, the prism table and the vernier table. Now, the telescope is provided with a clamping screw. When we are tighten the screw, the telescope is clamped and we can unscrew it, then we can move the telescope. Similarly, there is a fine adjustment screw is there. With the help of that fine adjustment screw, we can move the telescope slightly. Similarly, the vernier table is provided with the two screws here. Now, when this particular screw is unscrewed, loosened, the vernier table can be rotated. The vernier table can be rotated. When it is kept tightened or clamped, now what happens that the vernier is fixed. Now, the vernier is not moving and there is a fine adjustment screw for the vernier. Now, for the adjustments of the telescope, initially the telescope is provided with an eyepiece. This eyepiece is pull in or pull out. Now, looking through the eyepiece or telescope, we can observe the crosswire. Just focus on a white wall. When the crosswire is clearly seen, we can pull in or pull out. Now, I am pulling it. Now, the crosswire is seen, clear. Now, that is the position of the eyepiece. Then the telescope is provided with a fine adjustment screw here. That means we can move the distance of the telescope. Now, for that, the telescope is focused to a distant object. Now, it is focused on a distant object. Now, rotating this particular screw, we can adjust so that the distant object is clearly seen. Now, I am getting the distant object clearly seen. So, that is the position of the telescope. Now, for the collimator, it is having a slit here. There is a screw by which we can adjust the width of the screw. Now, looking through the telescope, that slit is obscured because that slit is illuminated by the sodium vapor lamp. Now, looking through the telescope, we are observing the slit, and I can see the slit here. We can adjust the width of the slit so that the slit is narrow. Then, the fine adjustment screw of the collimator, this one is adjusted. Now, we can move the distance so that the slit is at the focus of the lens here. Now, we are moving the distance. When the slit is at the focus of the lens, the image that we obtain here is very narrow and clear. Now, I am getting a narrow thin slit at the telescope because the telescope is receiving the parallel rays coming through the collimator, and the prism table that can be raised or lowered, and we can place the prism over the prism table, and it can be clamped here, and it can be arranged at any height. Now, the prism table is also provided with 3 leveling screws. One leveling screw is here, the other 2 are here. By using the leveling screws, we can arrange the prism table perfectly horizontal. Then again the vernier table, it is a circular table. It is graduated from 0 to 360 degree, and each division is having a value of 0.5 degree or 30 minutes. So, value of one main scale division is 30 minutes. Now, there are 2 verniers, vernier 1 here and vernier 2 here. These verniers are marked 0 to 30. So, 30 divisions are there on the vernier. So, the least count of the apparatus is value of one main scale division divided by number of divisions on the vernier, that is 30 minute divided by 30, that is equal to 1 minute. So, we are having 2 verniers. At any time when we are taking a reading, we can take reading on vernier 1 and similarly reading on vernier 2, and we are tabulating that readings. Now, we will see the theory involved, how we can calculate the refractive index using the ID curve. spectrometer ID curve. Our aim is to draw the ID curve for the given prism and then to calculate the value of refractive index. Now for the prism, we are having the formula. If I1 is the angle of incidence and I2 the angle of emergence, then I1 plus I2 is equal to, minus R1 plus R2 equal to D, where D is the deviation, and R1 and R2 we can see here. R1 and R2 are the angle of emergence at the first phase and the angle of incidence at the second phase. So that is the prism formula. This is a prism formula. Where D is the angle of deviation. Now this is the deviation, angle of deviation. Then from this condition, when this D is equal to D, the minimum deviation, then what happens that this I1 should be equal to I2, and that is marked as I, and R1 is equal to R1 is equal to R2, and that is equal to R. Then our formula becomes this I1 plus I2, that is I plus I, that is 2I, R1 plus R2 becomes 2R. So what happens that 2I minus 2R, that is equal to D. Again this R1 plus R2 is equal to A. Therefore this 2R is equal to A, or R is equal to A by 2. Then we can calculate from this one, 2R is equal to A. So 2I minus A is equal to D. Because 2R is equal to A, 2I minus A is equal to D. Then the angle of the prism A is equal to 2I minus D. And from that again, from this equation, I we can write I is equal to A plus D by 2. I is equal to A plus D by 2. So the angle of the prism can be calculated using this formula 2I minus D, and I can be written using this formula A plus D by 2. A plus D by 2. Then we can calculate the value of refractive index mu using the formula mu is equal to sin I by sin R, but I we mentioned I is equal to A plus D by 2 and R is equal to A by 2. So mu is equal to sin A plus D by 2 divided by sin A by 2. Mu is equal to sin A plus D by 2 divided by sin A by 2. Now coming to the procedure part, the preliminary adjustments of the spectrometer are made, and then here we are not calculating the value of A directly, we are getting the value of A from this particular equation, that is A is equal to 2I minus D, that is from the ID curve we can obtain the value of A. So here our aim is to find the deviation D, because we are plotting the ID curve, the deviation D. Now this is the ID curve for a we want to calculate the deviation D for a particular value of I. So we are repeating. For each value of I, we are finding the value of D, and then we are plotting a graph. From that graph, we can obtain the minimum deviation D. So if you obtain the value of minimum deviation D and the corresponding value of I, so we obtain I and D here. Using that I and D value, we can determine the value of the angle of the prism using the formula 2I minus D. 2I minus D. Now we will see how we can get the angle of deviation. Now for that, we want to set the prism for a particular angle of incidence. Say for example, if you want to set the prism at an angle of incidence, say 40 degree, say I is equal to 40 degree, then you can calculate the value of 2I, that is 80 degree. That means here angle of incidence, that is equal to angle of reflection, and the total should be equal to 2I. So this angle should be 2I. Then the remaining angle, this one is 180 minus 2I. So what happens that initially we bring the telescope in a line with the collimator, and Vernier 1 and Vernier 2 are made such that Vernier 1 reads 0 and Vernier 2 reads 180. For that we are rotating the Vernier table. Now the telescope is brought to the position T1. That T1 is determined using the equation 180 minus 2I. So if I select I is equal to 40 degree, 2I is 80 degree, 180 minus 80, that is 100. So that means the telescope is turned through an angle of 100 degree and fixed. Now the prism is placed over the prism table, and the prism table is rotated such that we can obtain a reflected ray. So we obtain the reflected ray here. Now the angle of incidence is I. No need of taking any reading there. Just to obtain the reflected ray coincide with the crosswire of the telescope. Then the angle of incidence is I. Here I is equal to 40 degree. Now bring the telescope to the other side AC of the prism to observe the refracted or deviated ray. Then now we are getting the deviated ray. No need to bring it to the minimum deviation position that we are doing in other experiments. Here just observe the deviated ray. Now the telescope is brought in a position such that the crosswire of the telescope coincides with the deviated ray or the deviated image. The slit coincides with the telescope, crosswire of the telescope. That means we are observing the deviated ray. At this position T2 we are taking. So that's the first reading we are taking. We are taking reading corresponds to the position T2. And that reading is marked as say A. The reading corresponds to the refracted ray. Now move the telescope to observe the direct ray that we already observed initially. Once again we observe in the direct ray and check the readings of Vernier 1 and Vernier 2. Initially that is fixed at 0 and 180. Check and confirm it, and that is the direct reading. Now the difference between these two readings, that is the direct reading and refracted ray reading, gives the value of the deviation D. So we can see the table column here. Now the angle of incidence is at 40 degree. Then the angle of rotation of the telescope, theta, is 180 minus 2y, that is 180 minus 80, that is 100 degree we rotated. Then we are taking the reading of the direct ray. That reading is already we mentioned, that is one is 0 and the other one is 180. Now if it is changed, you have to take that new reading. Then we are taking the reading corresponding to the refracted ray, Vernier 1 and Vernier 2. Then the difference, that is the deviation, B difference of A. Vernier 1 difference we can calculate, Vernier 2 difference we can calculate, and we can determine the mean. Now we are repeating the experiment. We are repeating the experiment for another value of angle of incidence, say 45 degree. Now for that, initially the telescope is brought in a line with the collimator. The Vernier table is arranged such that one of the Vernier reads 0 and the other one is 180. Now rotate the telescope through an angle of 180 minus 2i. 180 minus 2i means 180 minus 2 into 45, that is 90. 180 minus 90, that is 90 degree. Now the telescope is fixed at 90 degree. Present table is placed so that the present table is rotated to obtain the refracted ray. Now the angle of incidence is 45 degree. Then as we before, coming to the other side and observe the refracted ray and take the reading corresponds to the refracted image, that is the reading B. Direct reading is again 0 and 180. Again we can calculate the separate, we can find out the difference, and that is we obtain the D. Now it is repeated for 50 degree, 55 degree, 60 and 65, and then we can plot a graph like this. From the graph we can find the value of I and the value of D, and using the value of I and D we can determine the refractive index using the formula sin A plus D by 2 divided by sin A by 2, where A is calculated using the formula A is equal to 2I minus D. Now let us see the experimental setup and experimental arrangement, or how we can determine the D value for different values of the angle of incidence I. The spectrometer arrangements are, the preliminary adjustments are completed, the telescope is focused and collimator is arranged, and now we can place the prism. Now we want to place the prism for a particular angle of incidence I, say I is equal to 40 degree. Now we will see how we can arrange for an angle of incidence 40 degree. Now for that, initially the telescope is brought in a line with the collimator, and looking through the telescope we can observe the crosswire, the image, the slit is observed there, and that is coinciding with the vertical crosswire of the telescope. Now the telescope is clamped here. Now we can move the Vernier table. The Vernier table is moved. So that one of the Vernier reads 0. Now here the Vernier is reading 0. Then the other Vernier 2 is reading 180. Now the crosswire is coinciding with the image. Now the Vernier is clamped here. Now we cannot move the Vernier. Now again the telescope is unclamped. Now the telescope can be moved. Now we have to decide. Now in the first case, that means when the telescope is in a line with the collimator, the total angle is 180 degree. Now we want an angle of incidence I is equal to 40 degree. So 2I is equal to 80 degree. Then 180 minus 2I, that is 180 minus 80, that is 100 degree. So we are rotating the telescope through an angle of 100 degree. That means we can observe here in our Vernier the reading is changing. Now fix the telescope when the reading of the Vernier 1 is 100 degree. Now the vernier 1 is reading 100 degree. Then the vernier 2 is reading 280 degree. 280 degree. So initially the direct reading is one is 0 and the other one is 180. Now the telescope is arranged. So here you can see that. Now this is the direct position. Now this angle is equal to 100 degree. And this angle, that is the angle between the telescope and collimator, is now 80. Now this is 80 degree. Now the prism is placed. Now the prism is placed in such a way that the light is falling on one face of the prism. It is falling on one face of the prism. The light incident here. Now we can adjust the height. We can adjust the height so that light is incident on one face. Now if the light incident here, now at an angle of 45, now this is the normal, I 45 degree, angle of reflection is also 45 degree, total is 80 degree. Now the light is reflected. Now we can rotate this one. Now rotating this one, observe through the telescope so that we are getting an image, and that image should coincide with the crosswire. That is a condition. So looking through the telescope, now I am getting an image here. Now I am getting an image here, and that image is coinciding. Now that image is coinciding with the telescope now. It is coinciding with the telescope, crosswire of the telescope. Now this particular prism is arranged for a particular value of I. Here I is equal to 40 degree. Now from that particular position, now need to take the reading, unscrew the telescope and bring the telescope to the other side. Bring the telescope to the other side to observe the deviated or the refracted ray. The deviated or refracted ray. Now I am getting the deviated or refracted ray here. Now the telescope is brought such that the crosswire is coinciding with the refracted ray. There is no need in this case to rotate the present table or vernier table to bring it into the minimum deviation. We are just taking the deviated ray. Now we obtain the deviated ray in coincidence with the crosswire because we are drawing the ID curve. Now we can take the reading. Now in vernier 1, the reading is, we can take the reading of vernier 1 and vernier 2. Now in vernier 1, the reading is 318 degree. It is exactly coinciding. So 318 degree in vernier 1. And in vernier 2, we want to take the reading. In vernier 2, the reading is, the 0 is coinciding with the reading 138 degree. 138 degree. So that two readings are noted. In vernier 1 it is 318 degree and in vernier 2 138 degree. Now from that values we can calculate the D value because we have the direct reading that we can check once again. Go to the direct position, again check the direct image is there or not. Now it is there, it is coinciding with the crosswire. Now the vernier is reading, here the vernier is reading 0 itself because it is earlier arranged for a 0 reading, here it is 180. So we have the direct reading and the reading corresponds to the deviated reading. From these two readings we can calculate the deviation or the D. Now we want to repeat for another value of angle of incidence, say 50 degree or 45 degree. Now 45 degree. Now then 2i is equal to 90 degree. So initially, now it is coinciding with the collimator image is coinciding with the crosswire. Now rotate the vernier table again. Now it is 0, so it is reading 0 itself. Now the telescope is rotated. 180 minus 2i. Now 2i is, I is 45 degree, 2i is 90 degree, 180 minus 2i, that is 2i, sorry 90. Now the telescope is rotated through 90 degree. Now it is fixed. When it is 90, when 0 is coinciding with the 90, now the 0 is coinciding. Here 0 is coinciding with 90, here the reading is 270. Now this angle is 90, you can see the angle is 90 degree. Then place the prism is already there. We can rotate the prism like this, such that looking through the telescope, we have to get the reflected image. Now I am getting the reflected image. And rotate this one such till the image coincides with the crosswire. Now the image is coinciding with the crosswire. Now at this particular position we can say the angle of incidence is 45 degree because the total angle is 90 degree. The angle of incidence is 45 degree. Now bring the telescope back on the other side to observe the deviated ray. Deviated ray. Now we are getting the deviated ray on the other side. Now I am getting the deviated ray here. Now the telescope is placed such that the crosswire is coinciding with the deviated ray. No need to bring to the minimum deviation position. We want to just take the deviated ray. Now take the reading corresponds to the vernier 1 and the reading corresponds to the vernier 2. Now in vernier 1 the reading is, we can observe the reading, that is 320 degree 20 minute here, and in vernier 2 the reading is 140 degree 20 minutes. So that two readings are noted. In vernier 2 it is 140 degree 20 minute, and in vernier 1 it is 320 degree 20 minutes. So that is a reading for an angle of incidence I is equal to 45 degree. Now the direct reading is 0 and 180. Using that direct reading and the reading corresponds to the deviated ray reading, we can obtain the deviation D. Now it is repeated for another value of angle of incidence, 50 degree, 55 degree, 60 degree and 65 degree, and in each case we can take the deviated ray reading and the direct ray reading, and using that value of angle of incidence I and the deviation D, we can plot the ID curve, and from the ID curve we can determine the I value and the angle of the prism can be calculated. Using that value of I and A, we can determine the refractive index mu of the prism. Now coming to the sample set of reading that we obtain to find the to draw the ID curve, we mentioned the value of 1 main scale deviation is 30 minute, number of division of the vernier is 30, so the least count is 1 minute. Now initially we fixed the prism at an angle of incidence 40, then the angle through which the telescope is rotated is 100 degree, then the vernier table is rotated such that vernier 1 reads 0 and vernier 2 reads 180 degree. So that is a direct reading. Now when it is rotated through 100 degree and we obtain the reflected ray, then the telescope is brought back and observe the refracted ray. And when we observe the refracted ray at the position T2, then the reading of vernier 1 is 318 and vernier 2 reading is 138. Now we can calculate the difference, that is A difference of B, that is the reading of direct ray and refracted ray, that is deviation D, that is the reading corresponds to 138. We obtain the difference 318. Now here we can see that this 0 is actually 360 degree. So we are taking the difference of 360 minus 318, that is 42. Similarly 180, that is vernier 2 reading, minus 138, 180 minus 138, that is 42. Then mean of these two, that is 42 again. Now it is repeated, the angle of incidence is changed to 45 degree, then for that we rotate the telescope through 90 degree, refracted image is obtained, the direct ray reading is again 0 and 180, then going to the other side we obtain the refracted ray readings as 320 degree 20 minute and 140 degree 30 minute. Now this 0 is 360 minus 320 degree 20 minute, that is 39 degree 40 minute. Similarly 180 degree minus 140 degree 30 minute, that is 39 degree 30 minute. So the mean is 39 degree 35 minute. Now it is repeated for 50 degree, 55 degree, 60 degree and 65 degree. In each case we calculate the value of D. So this is the D value that we obtain: 42, 39 degree 35 minute, 38 degree 30 minute, 39 degree 30 minute, 41 degree 30 minute and 42 degree 50 minute. Now we plotted a graph. Now this is the graph that we obtained. Now on the x-axis we plotted the I value. Now 30, 35, 40, 45, that means 20 division is equal to 5 degree, and on the y-axis we plotted, so 10 division is equal to 1 degree. Then D value is taken along the y-axis. Now this is the curve that we obtained, that is the ID curve. Now from this ID curve corresponds to this particular point, the deviation is minimum, and that value of deviation we obtained from the graph, that is 38.5 degree. or 38 degree 30 minutes, and the corresponding value of I for this D value, that I value is 50 degree. So, we obtain I value and D value from the graph, and using that I value and D value we calculate the value of A. Now, A is equal to 2I, now D value is 38 degree 30 minute and I value is 50 degree. So, 2I, 2 into 50, 100 minus D, 38 degree 30 minute, that is equal to 61 degree 30 minute, that is the value of angle of the prism. So, we obtain A. Now, we can calculate mu sin A is 61 degree 30 minute plus D is 38 degree 30 minute, divide by 2, divide by sin A by 2. That is calculated and we obtain 1.5094, and that is the result.